Hello guys, good evening everyone. Welcome back to 360DigiTMG's domain analytics program. It is the fourth day since we are doing the domain analytics program that too in web and mobile analytics. In the very first day that we have seen what are the applications of machine learning when it comes to web and mobile analytics, and we have seen different applications where exactly we can apply the machine learning models. And how can we improve the sales of the web or any mobile? So we have gone through that, and in the second day we have discussed about different phases when it comes to data science project, that is CRISP-ML. So whichever the industry is, irrespective of the domain, we will be going through the same 6 phases. Those are the CRISP-ML methodologies, cross-industry standard process, and machine learning in quality analysis. So we have discussed what are those phases and what we will be doing in each phase. That is on the second day. And then we have seen what are the different models we'll be having when it comes to machine learning, like supervised and unsupervised, and how we can train the model using the data set, different data sets. What happens when it comes to unsupervised learning, and what happens when it comes to supervised learning, that we have seen. And and we have seen the how to train the model when it comes to supervised, how we are supplying the training data to the model, and once the training is done, how we are evaluating, what are the evaluation metrics, comes to classification and regression. In classification, we have seen what is the confusion matrix. And when it comes to regression, we have a few, like mean absolute error, mean square error, and root mean square error. Why exactly we are using the root mean square error that we have seen. So these are the things that we have discussed in the last 3 day sessions. In today's session, we will be discussing about one of the supervised learning machine learning algorithm, like we have discussed yesterday. We'll be having 2. One is supervised. Let me go through what exactly the supervised and unsupervised learn quickly, and then we will get into the one of the supervised algorithm, that is k-means, and we'll see how k-means algorithm works, and we will be taking one use case scenario, and we'll apply and try to find out some inferences from the data. And the first, what is supervised? So whenever we are talking about the supervised, means supervision, under the supervision of something. Let's say you have a data set x1, x2, x3, x4. These are the input features we'll be having. Whenever you're taking the data frame, you need to have a input column. Then based on those only, input columns mean you can also call it as a independent variables. Based on that only, we will be doing the forecasting. Forecasting or the prediction. You can you can call either of these names. So we will be having the labels when it comes to supervised models. Based on those inputs only, we will be doing the prediction. When it comes to unsupervised learning, we will be having just inputs. We won't be having any outputs. So what does unsupervised machine learning do? Itself, it will recognize there's the different patterns. If there is any similarity in between the pattern patterns, it will simply group them into different categories. Whenever you have a unsupervised learning algorithm, it will simply go through the patterns, and it will recognize the pattern. Based on those patterns, it will simply group into different clusters. This is the unsupervised learning. In unsupervised learning, we'll be having different algorithms like hierarchical clustering and k-means clustering. The major differences between the hierarchical clustering and the k-means clustering? What happens when it comes to hierarchical clustering? Whatever the entries will be having, entries in the sense, what are the subjects that we will be taking? First, we will be considering, if you have n subjects, you'll be considering as n clusters. In hierarchical clustering, we'll be having dendrograms. We'll be considering whatever the entries will be having, that many clusters we'll be considering. Based on that, based on the similarity of each and every entry, we will merging them in a similar clusters. Something like if you have taken 10 entries, based on the similarity of those entries, we simply grouping into different groups. This is we will be doing when it comes to hierarchical clustering. But when it comes to k-means clustering, it will be a bit different. We'll see how k-means algorithm will work. Yeah, like I've said, unsupervised learning is a machine learning technique which models are not supervised using the training data set. What it does, it will itself go through the data set and it will find out the hidden patterns. Based on those patterns, if we have similar patterns or homogeneous group, it will simply group into different clusters. Yeah, instead models themselves find the hidden patterns and insights from the given data. It can be compared to the learning which takes place in the human brain while learning the new things. So it will simply group them based on the similarity. This is a unsupervised learning. Yeah, you can see here, let's say these are the different data points we'll be having. These are all different data points we'll be having. Based on the similarity, it will simply group into different categories. But how does these the processes happens? So upfront, whenever we are talking about the k-means clustering, the k-means clustering, the name itself saying k-means means average, that we will be taking average value to decide which cluster it belongs to. So whenever you are passing the k value upfront, it could be anything. K is equal to 1 or k is minimum we will be taking 2, 3, 4. Any value that you are passing, it will simply assign those centroid. Let's say you have taken the k value is equal to 2. It will simply assign 2 centroids, just 2 centroids. Based on that, it will keep calculating the distance between the other points from the center. Each and every point, it will simply calculate the distance between each and every point. We will see that in a minute. So what it will do, simply based on the similarity, you can see these are the similar patterns we'll be having. So it will simply group them into individual categories. This is how clustering works. We will see in detail how k-means works, but this is overall idea of the k-means clustering. K-means is one such unsupervised learning method that aims to group similar data points in clusters. It allows the cluster the data into different groups and convenient way to discover the categories of the group in unlabeled data set. So whenever you have unsupervised learning, we'll be having the unlabeled. We don't have any label. That is, we don't have any outputs. Without output, we will be having the data frame. That is why we'll be calling it as unsupervised. It is centroid based algorithm where each cluster is associated with center. So whenever you are passing the k value upfront, so whatever the value that you are passing, that could be 2, that could be 3, those are acts as a centroid. The main aim of the algorithm is to minimize the sum of the distance between the data points and their corresponding cluster. That means, see, what is cluster? When can we say that whatever the cluster that we are forming, giving the best results or making sense or it is feasible? How can we say that? Let's say, yeah, take this diagram only. Whenever we can say that whatever the cluster that we are forming is a good cluster, we need to have within the sum of the square, the distance between within the cluster, it should be as minimum as it should be. Whatever the distances we'll be having in each and every data point, it should be as minimum as it should be. It is within the cluster, and the distance between the cluster and the distance between the cluster should be as high as possible. This is within the clusters. It should be packed, so that we can say, yeah, whatever the cluster that we are formed is giving the best. It should be as less as possible, and the distance between the clusters within the sum of the square and this the between the sum of the square. Within the sum of the square should be as less as possible. When it comes to between the sum of the square, the cluster, I mean, distance between the cluster, it should be as high as possible. That is what that statement is saying about. What are we trying to do? The centroid based algorithm. Each cluster associated with the centroid. The main aim of the algorithm is to minimize the sum of the distance between the data points and their corresponding clusters. Same, if you have data point something like that, it will try to decrease the distance between those points, so that whatever the cluster that we are forming, it makes sense. And when it comes to other cluster, the distance should be as high as possible. Then only we can say that, yeah, whatever the cluster that we are forming are giving the good results, are making sense. So how does that clustering happens? How does k-means cluster happens? We'll see that step by step. So, yeah. Unlike unsupervised learning, unlike hierarchical clustering, what we are doing first in hierarchical clustering, we will be simply doing the dendrogram. Like that, we'll be having dendrogram. By looking at the dendrogram, how many clusters are making sense? Based on that, we will simply draw a line. If you think that 3 clusters are making sense, in that case, you can simply draw a line based on that. And you think these are 4 clusters that are making sense, just by looking at the datagram itself, we'll be drawing the line, and that clusters we are taking. But when it comes to k-means clustering, initially we are passing the k value. Initially, we are passing the k value. That could be any value. Normally, we have different methods, to calculate what is the k value. Previously, in old generation, we'll be having how to calculate the k-means k value. That is under root n by 2. These are n are different number of patterns you will be having. But nowadays it doesn't make any sense. If you have n is equal to 50, if you have just 50 data points, these are n is equal to data points. When you have n data points is equal to 50, you are making how many? By 2 means 25. It is 5. You have just 50 data points. In that you are making 5 clusters. It doesn't make any sense, right? So that method is outdated. We are not using that method anymore. Instead of, we will be going for scree plot. What is the scree plot? We will be discussing shortly. So to decide the k-means, we can simply go with the scree plot. So previous to that, we will simply giving some k value. K value ranges from any value, but it should start from 3. Then only we can make 2 clusters. If you mention k is equal to 1, in that case, the data set, whole data set is considered as a single cluster. Single cluster. So that doesn't make any sense, right? So we have to give at least 2. K value should be at least 2. Yeah, upfront we are passing the value of k. Is one such unsupervised learning method that aims that group similar data points. So what happens right after passing the k value? So whatever the data set will be having, let's say, yeah, this is the data set you'll be having. Let's say this is a data set we'll be having. And you are passing k is equal to 2. Whenever you pass k value is equal to 2, automatically 2 centroids are formed. 2 centroids will be formed. And then the distance between the centroids to other data points will be calculated. Each and every data point. Each and every data point. Each and every data point. It will be calculated. Distance will be calculated. Similar to that, from that second data point as well, centroid as well, the distance will be calculated. Based on that distance, it will calculate the mean value. Based on the distance, it will calculate the mean value, and then this center passes through wherever the new mean, wherever the right after calculating the distance of all, wherever there is a new mean, it will simply pass to new centroid. Similar to that, this is also passes to the new centroid. Let's say we have new centroid here, and here the new centroid. Again, it will calculate the distance between all the data points. Even this, it will calculate the distance between all the data points. It will calculate the distance between all data points. Based on that, again, it will calculate the average or mean of the data. Wherever there is a new mean, it will simply shift to that mean. Like that, how many times it will happen? Until and unless there is no change in new centroids. Until and unless there is no change in the new centroid. Something like that, it will keep happening. So until and unless there is no movement in the new centroid or little movement, like that, we will be forming the different. That is when k is equal to 3. What happens? That is k is equal to. What happens when you have a k is equal to 3? Similar to that, say whenever you're passing the k value is equal to 3, it will take centroids. It will take 3 centroids, and then the same process begin. Based on that, it will calculate the distance between the centroid to all the other points, and whenever it is calculating the distance, based on that, again, it will calculate the mean of that value. Wherever there is a new mean, it will simply navigate to that value as a new centroid. Like that, it will keep happening until and unless there is no movement anymore. And then finally, the clusters will form. So what happening? When k is equal to 2, when k is equal to 3, or k is equal to 4, k is equal to 5, 6, something like that, you can make any number of clusters, whichever, and then once the clusters are formed, in that case, what we'll do, we'll simply calculate in the mean. Wherever there is a good variance, in that case, we will consider that as a good cluster. This is a process we'll be going through when we are forming the k-means clusters. Here, first initializing centroid for each sample in the set of example. So you will you can give any value, k is equal from beginning from 2. Once the k value is assigned, it will be calculated. It will calculate the distance. What is the Euclidean distance here? It is simple. It's simply the distance between 2 points. Let's say these are the data points we'll be having. Let's assume it is the data points we'll be having. Yeah, and these are the two. K is equal to, we have taken 2 first. These are the 2 k values. In that case, what happens? It will calculate the distance between all the points. That is, we will be using Euclidean distance. What is the Euclidean distance? Distance between the 2 points. This we will be considering this as a centroid, and the distance between that. How much it is? x2 minus x1 whole square plus y2 minus y1. This is the distance between 2 points. That is also this is also we will be calling that centroid. Like that, we will be having so many, right? So we have to add r. Up to n numbers we will be calculating. Whatever the values that we are getting, for that we will be calculating the mean. Wherever there is a new mean, we will simply navigate to new centroid. Let's say if it is a new mean, in that case, we will simply navigate to the new point. Again, we'll be calculating the same. Again, we'll be calculating the same. Based on that, we will be calculating the mean of that value again. And if it is moving again, in that case, it will find the new centroid until and unless it will become constant. There is no movement of centroid. In that case, we can say this is the best model. For each cluster in the set of cluster, recalculate the cluster centroid based on the mean of the sample in the cluster. So once it is done, we will be calculating the centroid based on the mean of all the sample in the cluster. Repeats 2 and 3 until and unless it will become stable. Determine the variance of each cluster and sum of the square of errors. So what is the sum of the square of errors? So we have cluster something like that. The distance within the sum of the square plus the distance between the 2 clusters within the sum of the square plus between the sum of the square. Total we will be calling it as sum of the square error, SSE. Wherever it is having the highest value, that we will be considering as a best cluster. Repeat the steps 1 and 5 with the different initialization of clusters centroid positive. The same we will be repeating until and unless all the clusters are cluster centroids are the same. So what are the advantages of k-means clustering we'll be having? What are the disadvantages of k-means clustering we'll be having? Yeah. So why this? What are the advantages when it comes to k-means clustering? K-mean is the most used clustering method Yeah, normally, when compared to the unsupervised hierarchical clustering, it is mostly used because it is computationally inexpensive. All we are doing is what? Simply calculating the Euclidean distance. Based on the Euclidean distance, again we are calculating the mean. Based on that only, we will be forming the cluster. So it is, we are not doing that many calculations. So it is not computationally not that much expensive. It can scale well with the large data. Whenever you have a large data, what happens when hierarchical clustering? So you won't even able to understand how many clusters you will be having. Like if you have 50,000 or 100,000 data, in that case you can't even, the cluster will be something like that. You won't even recognize how many clusters will be having. So in that case, it is not possible to determine how many clusters we want when it comes to hierarchical clustering. But when it comes to k-means clustering, we can easily find out how many clusters we want by using the scree plot. See, scree plot, you can use simple scree plot and you can find out the number of clusters you want. And it is an appropriate method when you know the number of clusters to be drawn from the data set. When it comes to the hierarchical clustering, based on dendrogram, we will be deciding how many clusters, the clusters possible clusters. But when it comes to here, if you know already, since if you have domain knowledge, if you know the if requirement SME, subject matter expert, told you to form these many clusters, like specific amount of clusters they want, in that case you can simply pass those cluster value upfront and then you can do the clustering. What are the limitations? Limitations will be having? Numbers of clusters must be chosen upfront. Yeah, it is a bit hard to come up with the clusters in the very early stages. If you don't have a knowledge of that particular domain, in that case, it is not possible to guess the number of possible number of clusters. So yeah, it is one of the limitations when it comes to, and outliers can have a strong influence since the model is based on the k-means. K-means means average. Based on average only, right? We are simply changing the centroids. Changing the centroids are newly formed. So it is mean whenever mean is included, and if you have outliers, so it will definitely get affected. Whenever you have outliers, instead of going for the mean, we will be going for more median rate. Why? Because mean is getting affected with the outliers. So since k-means, name itself is k-means, number of k values, based on mean, we will be calculating the clusters. So mean, because of this mean outlier, if you have outliers, it will definitely get affected. So it is one of the limitations. Initial centroid positions have strong influence on result. See, whenever you are changing the centroids, the first centroids only have the change, the centroid, new centroid forming. The changes are strong when it comes to very first one. The next one, you won't be finding any much difference. Let's say you have calculated the centroid of randomly, you have given centroid, the very first centroid, and then you have calculated mean. In that case, there is high chance of moving. The distance will be high, the moving distance. And next, whenever you're calculating the moving average, again there is no movement. I mean, there won't be that much movement. That is why it is called as strong influence on the very first centroids. Does not cluster well with cluster of varying size densities. That's not cluster. So these are the limitations we'll be having when it comes to k-means clustering. And one more thing, whenever you are having the cluster movement or changing to median, a new centroid movement. So there might be cases when a cluster might be oscillating. It is one cluster and it is one cluster. There might be chances that the one point can keep oscillating in between two. In that case, you won't be forming any clusters. Does not cluster well with a cluster of varying sizes. It will keep changing. In that case, you won't be forming any clusters. You won't be able to form any cluster. That could be, in that case, keep changing. I mean, whatever the cluster, like if you have formed one cluster in the first iteration, and if you do this second iteration, you won't be getting the same values. It is also one of the limitations when it comes to k-means clustering. Yeah. For stability run, the k-mean clustering multiple times. So in order to avoid that, each and every time we will be getting the different clusters, right? To avoid that, what we'll be doing for stability run, the k-means clustering multiple times called as we have to do multiple iterations with the randomly chosen values. We have to choose random different values. K is equal to 1, 2, 3, 4, something like that. We have to choose different values and you have to run again and again until and unless local minima values found. Local minima values means in order to decrease the error rate. So what happens whenever we are working on the gradient based algorithm? So local minima will be randomly you are choosing some value when it comes to k-mean. Randomly you are choosing some values and you will come down to this point, but we doesn't know whether this is a local minimum. We need to reach global minimum, but it could be the local minimum. In that case, the error rate of the data you won't be able to decrease. Randomly, you might be getting into the local minimum. Let's say this is global minimum. Global minimum. And you have point, the random point from here, and you have keep decreasing the values in order to decrease the error rate. And if you have found this value, the lowest value, and you will be considering, the algorithm will be considering this is a global minimum. But is it the normal global minimum? No, it is the global minimum. Here you will be getting the least error. In order to find that error, or in order to decrease the error to the global minimum, we have to keep doing the iteration, multiple iteration we have to do until and unless we find the global minimum. So normally when it is start increasing, it will stop right here only. It will consider this is only the global minimum. So in order to avoid that, we have to run the algorithm with different k value. Yeah, this is the point that I'm talking about. A data point might be keep oscillating between two clusters in each of the runs. So whenever some data point, let's say you have centroid here one, when you are taking just two centroids, centroid two, and there is a point in between. Whenever mean is changing, when you are moving here, it will become this cluster. If move mean is also moving here, in that case it will be this cluster. In that case, what happens? It is keep oscillating. The value is keep oscillating between two clusters. In that case, it won't be giving you any results. Data point might be oscillating between two clusters in each of the runs, and algorithm will enter infinite loop. It will be keep oscillating. You won't be finding any proper results. Does this choosing the convergence criteria or by specifying the map So in that case, to avoid this, what we have to do? We have to specify maximum number of iterations. Maximum number of iterations. What happens then? If once, if you have come across case something like that, when you mention the maximum number of iteration, whenever maximum number of iteration limitation is reached, if it is in this cluster, it will become that cluster and the rest. So something like that, we can stop if you have running into the infinite loop. So this is one of the limitations when it comes to k-means clustering. That is called conversion criteria. Is to stop cluster centroid moves less than certain percentage of small distance between the any of the centroid. So whenever we are having forming the clusters, what we are doing, we have to decrease the within the sum of the square. The data points. Here one more data point, or you can say cluster. We have to decrease this within the sum of the squares, so that we can form perfect cluster. This is within the sum of the square, and it is between the sum of the square. Total we'll be calling it as TSS, total sum of the square. And compare between the cluster variation and cluster within the cluster variation and between the cluster variation. This is between the sum of the square as well as within the sum of the square. Some of those will be calling it as sum of the square of the error. Based on that, we will be judging the cluster. To decide the k value of k-means, we will be having this scree plot. It is also scree plot. We'll be also calling it as elbow plot. Elbow plot. We'll be getting something like that. Whenever it is, the value, whatever the values will be having at elbow, that we will be considering as a good. At that point only, it might be performing good, but we are not taking exactly that. You can do iteration, beside values as well. Based on that, wherever you are getting the good, cluster that makes sense, that value will be taking as a best cluster. Based on this, we will be having one use case scenario. We'll go through that use case scenario and we'll see how can we apply this k-means clustering when it comes to real life. Or we'll do one use case scenario and we'll try to understand how can we implement this k-means. Business objective of this particular use cases, we have to group different people based on their interest. If you want to go to some particular place, based on, we will be getting Google reviews, right, in each site. If you have some particular place, we will be getting ratings and reviews. Based on those people, which places they are interested, which places they are liking. Based on the ratings and reviews, we'll try to group them into different categories. We'll be taking different places like churches, pubs, beaches, all the reviews, different reviews we'll be taking. Based on that, we will try to group the people into different categories. That is a business objective of business objective. So here, in order to import pandas as PD. In order to do the manipulations or data manipulations, we'll be using the pandas. And in order to do the calculation, that mathematical calculation, will be importing the numpy. And matplotlib in order to do the visualization. In order to do the visualization, we'll be using the matplotlib. And this is also Cborn as SNS. It is also visualization. It is also for visualization, but a bit advanced visualization compared to the matplotlib. Advanced visualization, you can say. So let's get into the features. What are the features we'll be having, or attributes? These are the attributes we'll be having in our data set. What are those? Average rating. So since we are taking the average ratings, in that case we'll be averaging all the ratings. Average ratings on churches and resorts, beaches. These are the different we are taking features that we'll be taking. Parks, theaters, museums, malls, zoo, restaurant. These are the different features like that. We'll be having 25 features, and we are importing that is a Google the Kaggle data set only. If you want to, you can simply Google it, and you can take that data set and you can work on it. Yeah, these are the different ratings we'll be having. User 1, how many users will be having? About 5,000 entries will be having, 5,456. So this is the data set. These are all average ratings we'll be having. Exploratory data analysis, we'll see whether we have any values or not, and try to describe the data, what exactly we be having, and info, what are the details, details of data set. We'll look into it. How many columns will be having? 24. And how many? 5,456 entries will be having. Describe function. What could be the mean value, minimum value, maximum value? These are the describe function will give you. Just look into it. Since we are taking all ratings, minimum value will be 0 and maximum will be 5. For all, will be having the same. Beaches, parks, the rating will be the maximum, right? So we'll be taking mean. What could be the average rating? You can simply see churches, you have average rating. Since resorts, average rating is equal to 2.3. Restaurants, average rating has 3.1. That is the maximum rating we'll be having. Average rating, average of all the ratings. And then we'll try to find out whether we have any null values or not in this data set. Since we have null values in restaurants and pubs and gardens, so we have just one null value. So instead of just imputation, we'll simply dropping those columns, dropping those entries, we're dropping those NA values. And then we'll try to visualize what are the ratings we'll be having for different overall rating distribution. You can see what are the distribution of ratings. Churches are in between 0.5. Normally, the reviews will be having 0.5 to 5. 0.5 to 5. So these are the churches rating. You can see maximum ratings are present in between 0.5 to 2.5. Beaches are in between. Maximum people are seems like in the beaches. parks, pubs, viewpoints. These are the different distribution, rating distribution will be have. Now we are applying the k-means clustering on that so that we can group them. Whatever the people who have done the ratings, we can simply group them into different categories. Which people are preferring what? Whether they are preferring to go to beaches, or they want to go to food places, or they want to go to or any churches or something like that. We'll try to do that. So in order to find out the k value, we are supposed to do the scree plot. We'll try to do the scree plot for different with PCA confidence, since we do have 0 to 5 only ratings, right? We don't need to do any normalization anyway. Even though you do the normalization, it won't change much. Yeah, we are trying to find out what could be the feasible k value. Standard scalar. When exactly we'll be using the standard scalar? If you have variance in data, in order to convert that variance into standard. If you have too much variance in between input variables only, in that case we'll be using, but here we don't need, and we are using the PCA decomposition technique, and we are checking whether we have good k value, whether just scree plot, selecting the k value, data type original and the scale. This blue is actual data without applying any PCAs, and then we will be doing the scaling. That is, we will be using the standardization, that data, that is yellow line, and PCA will be having that purple color is the PCA, and PCA, after doing the PCA, we'll be doing the standardization. It is not necessary. Is that the? As you can see, the 5 seems like it is good cluster to go with. Anyway, you can do iterations as well, like 3, 4, or 5 nearby, whatever the values will be, k values will be, and you can do the iteration wherever you're getting the mean value is better. That you can take it as a good value. Then we are applying the k-means clustering. Where clusters, how many we are taking? 4. See, these are the clusters that we found. These are the people who love to go juice bars, hotels, and other art galleries, burger, pizza shops. These are the people who love to go these places, and these are the people who love to go to gym, bakeries, swimming pools, beauty and spas, dance clubs, caves. And these are the people who want to go to malls, restaurants, local services. And these are the people who will love to go to the resorts, beaches, parks, theaters, something like that. Based on their likes, you can simply categorize into different clusters. These are the data that we have taken from the Google set, from web. So what can you summarize? The cluster 0. Cluster 0, the green one. You can say user who prefer nature like beaches and park, and also love to go to the museums and theaters, that you can say. When it comes to cluster 1, These are the food lovers. Pay attention to the hotels and juice bars, and also have a art in there. Yeah, maybe. Yeah, that you can infer from this orange. And the light blue, activities finder. This type of user allowed to go to the local services, spend their time in shopping mall. These are the inferences that you can make using the cluster. And cluster 3s, that is a pink. Are not loosely spread. They might not be share common interest, something like. Yeah, most of the day you can see here it is the packed one. Here it is also a bit of packed and it is also packed, but here you can see they are widely spread. Maybe they don't have like strongly similar qualities. So these are the inferences that you can make by the clusters. And you can also go with one more cluster and you can find out what kind of which kind of places people are visiting. There is one more cluster, love beaches, park, theaters, and museum. And you can, yeah, these are the similar kind of cluster that you can form. Yeah, this is the K-means algorithm and how you can the unsupervised learning. One of the unsupervised learning K-means algorithm, and how can you apply that K-means algorithm when you are taking in real-time data. And this is a use case based on interest of the people, based on the rating they have given. You can simply categorize them into different clusters, and you can make inferences from those clusters. Yeah, thank you for joining, guys. I hope you guys learned something from this video. And if you are want to transform your career, or you want to kickstart your career into data science, we'll be having the tame Python sessions are going on. Tame Python sessions are going on that are conducted by the CEO Bharani sir himself. So if you want to kickstart your career into data science, please go through 360DigiTMG channel, and you can go through all the Python videos for free. And yeah, thank you for joining us, and we'll see you in the next class with one more use case scenario. We'll be having KNN algorithm, K nearest neighbor algorithm. That is supervised algorithm. We'll be taking one use case scenario and how we can apply that KNN algorithm when it comes to real-time cases that we'll see in the next class. If you are interested, please join the next session as well. And yeah, have a nice day, guys, and we'll see you in the next session.